I'm Brandon Free.
And our senior design is on 3D printing hydrogel materials. We have been working with alginate material, so we are trying to increase that print resolution. So we have taken the base of that material, which is alginate, and added additives such as a nanoclay, and then to thicken it, and then calcium to help cross-link it. And we're hoping that that would be able to increase the print resolution to have to print not only simple geometries but more complex geometries.
So to talk a bit about the printer itself, so we wanted to design something new that would be cheaper and would offer a thicker material to be printed with, because we thought that that would yield a better result. And so we came up with this design here. We actually 3D printed it at the library here on campus, and that allowed us to print things that were a lot thicker and have better control over flow rates with like really thick, different viscosities of materials.
One property that we knew that we wanted our material to have would be shear thinning. So the viscosity starts high, but then as you apply a force to it, it seems to thin, which makes it a lot easier to push through the printer. And alginate's known to have those properties. The viscosity starts out relatively high and then decreases as we apply more of the force, which makes it easier to print. And then here at the bottom, you can see these top two lines are the ones that incorporate both the calcium and the nanoclay, and they actually gave the best results in having the highest viscosity while allowing it to thin enough to be printed. And so here you can see this is a 3D printed square of just alginate, and it looks nothing like a square because it's not thick enough to hold its own shape. Where when you do add the calcium and the nanoclay, it's able to hold its shape better. And when you look at this from the sides are actually vertical, showing that if we would be to build it up more, it will hold its shape better.
So in the future, we would like to further optimize the printing mechanism to try to introduce things like better air pressure and better things that allow us to dry even thicker materials. And then eventually we could use this base formulation with the addition of other chemicals to get toward that end goal of making medical simulation devices.